Okay, now we're going to work on the second part of 2.4, which is compound inequalities. So two inequalities joined by the word and or the word or constitute a compound inequality. So compound inequality is basically two inequalities in one problem. So the graph of a compound inequality with and is the intersection of the graphs for both inequalities, and the graph shows numbers that are solutions to both inequalities. You may see that symbol, it looks like an upside down U, and that means intersection. So this inequality here, 2 is less than or equal to x is less than 5, really means anything greater than or equal to 2 and also less than 5. To graph this on a number line, if I put 2 here, 3, 4, and 5 here, anything greater than or equal to 2 would be a closed circle at 2, and less than 5 would be an open circle at 5, and anything in between. So when we have problems that are and types of compound inequalities, which means they are sandwiched in between the variable like this, the solutions are going to be between two endpoints. So the possible numbers that can be solutions for this compound inequality are really anything that's greater than or equal to 2 or anything that's less than 5. So examples could be like 2 is a solution, 2.5, 3, 4.1, 4 and 7/8. But would 5 be a solution? No, 5 would not be a solution because 5 is technically not part of the solution set since it's an open circle and everything less than 5 is a solution. The graph of a compound inequality with or is the union of the graphs of both of the inequalities. So for example, if we have -2 on here and we have 1 on here as well, then anything less than or equal to -2 would be a closed circle at -2, and the solutions are to the left. Anything greater than 1 would be an open circle at 1, and the answers would be anything to the right. Notice these solutions are going the opposite way. So these solutions are pointing towards positive and negative infinity. So even though there's infinite solutions in the first example and there's infinite solutions in the second example has a lot more going on because these solutions are going both ways. So numbers that are possible solutions could be anything that's less than or equal to -2, like -100, -30. -2 is a solution. And also anything greater than 1, like 1.0001 would be a solution. 1 would not be a solution because it's an open circle, but then anything greater than 1 as well would be a solution. And we could keep going here forever. Now we can use interval notation for these types of problems as well. If we look for the and compound inequality, this would be bracket 2, comma, 5, parenthesis. For the second one, for this compound inequality, this would be -infinity, comma, -2, bracket, union with parenthesis 1, comma, positive infinity, parenthesis. So yesterday we learned about interval notation, and we use this for compound inequalities as well. So in example 4, we're solving compound inequalities in our notebook. I'm going to do the first one with you, and then I'm going to have you try the second one. So when we're solving inequalities like A, -7 is less than or equal to 5x minus 2, which is less than 8, you're basically solving two separate inequalities. The first inequality you're going to solve is this one here. It's going to be -7 is less than or equal to 5x minus 2. And then you're also going to solve a second inequality, which is going to be the second part of this, which is the middle to the end. In green, 5x minus 2 is less than 8. So for both of these inequalities, you are going to be doing the same type of process. Since 5x minus 2 is in both, you're going to be adding 2 to both sides first. -7 plus 2 is -5. And when I divide by 5, I get -1 is less than or equal to x for this one. And then for the second one, I add 2 to both sides. I get 5x is less than 10. I divide by 5. I get x is less than 2. So my two solutions are here. Anything greater than or equal to -1 and also anything less than 2. So on my graph, I would need my two endpoints, -1 and 2. For -1, this would be a closed circle. For 2, it would be an open circle. And the reason why is because of the fact that -1 is a solution, whereas 2 is not a solution. Anything that is greater than or equal to -1 and also less than 2 would be in the middle here. So that would be my graph. And then my interval notation would be bracket, -1, comma 2, parenthesis. Why don't you stop the video and try letter B? Okay, let's go over letter B. So first thing I'm going to do is split this up into two separate inequalities. -3 is less than -2x plus 1. And -2x plus 1 is less than or equal to 9. Then I'm going to solve both of these by first subtracting 1 from both sides. I get -4 is less than -2x. Divide by -2 and be very careful here. -4 divided by -2 is a positive 2. We have x here. But because I divided by a negative, the sign is going to flip from a less than to a greater than. For this one, subtracting 1 from both sides, I get -2x is less than or equal to 8. Dividing by -2, the same thing's going to happen. The sign's going to flip from a less than or equal to a greater than or equal to -4. So the two numbers I need on my number line are -4 and 2. For -4, it's going to be a closed circle. For 2, it's going to be an open circle. Anything that is less than 2, so x is less than 2, would be to the left of 2. Anything greater than or equal to -4 would be to the right of -4. So my solutions are in between. This would be bracket -4, comma 2, parenthesis. Now, letter C is different. It's not going to be an AND compound inequality because in letter C, I can actually see the word OR. When you see the word OR, you know your answers are going to be going towards the positive and negative infinity. But when you have a sandwich problem, you know it's going to be an AND compound inequality. So for OR compound inequalities, all you're basically doing is solving both of the inequalities separately. So if you want to pause the video and try this on your own, go ahead and do it. If you're not comfortable yet, then follow along with me. Step 1, for this first one, I'm going to add 5 to both sides. I get 3y is less than -3. I divide by 3, and I get y is less than -1. Notice, I do not flip the sign because I did not divide by a negative. Or the next one, adding 1 to both sides, I get 2y is greater than 6. Dividing by 2, I get y is greater than 3. So my two endpoints that I need on here are -1 and 3. Anything less than -1 would be an open circle, answers to the right. Anything greater than 3 would be an open circle, answers to the right. Did I say right the first time and then left? So these are pointing towards positive and negative infinity. So my interval notation would be negative infinity in parentheses and then -1. This one would be parentheses 3 to positive infinity, held together with a union like that. Okay, on the next page, we are looking at translating verbal statements and then using these problems to try some applications. So what I want you to try to do is go through A through D and try and figure out what these verbal statements would be in inequality form. And if you're feeling up for it, try the applications.